Subtracting functions. I will admit, this is not quite as useful. I'll show you how to do it, and then I'll show you how to avoid having to subtract functions. So subtracting functions will do very much what we did when we added them. We'll imagine a straight line at a variety of points. We'll calculate some y values. This time, instead of adding them, we'll subtract them. That will give us some new points, and we'll plot those new points. So let's see what we get. So we'll look for stationary points. Yeah, there's nowhere that equals 0, so that's not really going to help. Okay, y value of 0, y value of -4. We're taking the y value of 0 minus the -4. So that ends up at 4. Y value of 2 minus a -4. That'll take us to 6. Y value of 4, y value of -4, 4 minus a -4 takes us to 8. So this side of the graph looks like that. Y value of 3, y value of -4, 3 minus -4 is 7. Y value of 0, y value of -1, that'll take us to 1. We think this is what's happening. Maybe we should check another point just to make sure. Y value of 2, y value of -3. That gives us a y value of -5. Looks like we're on the right track here. Probably changes shape a little bit there. And what's going on here? Y value of 2, y value of -3. That'll go up to 5. So very much like we did yesterday, only we're subtracting instead of adding. So you can do that. But when you're asked to do it yourself and you're asked to draw some functions on your own, I'm going to give you a slightly better way of doing this. So let's look at the slightly smarter way. We have f of x and g of x. We're going to draw f of x. But if I know I'm going to subtract, instead of drawing 1 over x, I'm going to draw a -1 over x. And why would we do that? Why would we want x and -1 over x? Because then we're just subtracting them. But to draw the graph, we get to add the values. So think of this, instead of subtracting, as adding the opposite. Why? Because it's always easier to add. Okay, let's see if we can get the graph. So these are our two graphs. We're going to add these two. So I'm going to start here at 1. At 1, I have 1 and -1, so that's going to give us an x-intercept. So there's an x-intercept here. As we move along this line, the green line dominates because it's bigger. We're adding very small negative numbers. Here we're adding -1/2, -1/3. So it pulls this graph down just a little bit. So we're going to stay just below that line. Okay, my drawing's pretty atrocious, but don't worry, I'll get you a better one later. So we're just going to stay below that line. We're going to approach the line, but stay below it. Why are we below? Because we're adding negative numbers. What happens on the other side? Who dominates in this section? Which values are larger in size? Again, we don't care about the negative. We're just comparing the numbers themselves. So in this region, the red graph dominates. So we're going to be much closer to the red graph. Are we above or below the red graph? You're adding little positive values, which will raise the graph up. So we're going to just stay a little bit above the red graph. Look at that beautiful smooth curve. That's awful. I'll give you a better graph in a bit. At this point, we're adding 0 and nothing. So we have ourselves an asymptote. And that's good because that will help us figure out what's going on down here. We're going to approach the asymptote. All right, can we find out what's happening here? And why do I keep going to -1? The reason I keep going to 1 and -1 is that's where the two values match. So the two values match. We have another x-intercept. Okay, let's do the left. On the left side, the green graph, the y values are larger in size. So we're going to be closer to the green graph. And we're adding little positive values. So we're just going to stay above that green graph. So above the green graph. On the other side of -1, it's the red graph that dominates. Those are much larger in size. And are we above or below the red graph? We're adding little negative values. Little negatives will draw that down. So it'll stay just below where it was before. Okay, for a much better looking graph, let's check this out. So I'll get rid of mine and we'll look at this one. So let's do this again. At 1, we added 1 and -1, gave us the final answer of 0 on the blue graph. At 2, we added 2 and -1/2, that dropped it down. 3, -1/3, dropped it down. 4, -1/4, dropped it down. You can see we're getting closer and closer to this green graph, but staying just below it. On the other side of 1, it's the red graph that dominates, which is why this blue line is much closer to the red graph now. And are we above or below the red line? We're adding little values, little positive values from the green graph, which is why the blue graph stays slightly above the red. The closer we get to 0, the closer we get to the red graph. Why? Because we're not adding very much. There's an asymptote at 0 because there's no red graph to add in. At -1, we added a y value of 1 and -1 and got a y value of 0. On the left-hand side, it's the green graph that dominates because they're larger in size. So we stay very close to the green graph. We're above the green graph because we're adding little positives. And the further out we go, the smaller the value. So that blue graph gets closer and closer to the green line. On the other side of -1, it's the red graph that dominates because those values are larger in size. Are we above or below the red graph? We're below because we're adding small negatives. The closer we get to 0, the closer the blue line gets to the red graph because these values are smaller and smaller. And that is what your final answer looks like. So when you're working today, if you are asked to draw the graphs yourselves, put the negative in on the second graph so that you can just add them. Let's look at the domain of this graph. Told you it's the reals and not equal to 0. So why is that? Domain of the first graph is x is a member of the reals. Domain of the second graph, x is a member of the reals, but x cannot equal 0. Domain of the final answer, we have to exist on both graphs. So this says I can be anything, but this has a restriction. So that's why your final answer contains all the restrictions from any of the graphs that you've been drawing. So f of x, anything, g of x, anything but 0. The subtraction of the two graphs then has to include all restrictions. Okay, not very much to do today. Really, once you've done a couple of subtractions, you're going to end up adding the opposite and getting a little bit of practice in what you did before.